2. Hello everyone, I'm James. I'll be chairing this session. Our first speaker today is Helen. Just due to time constraints and length of talk, we won't do questions at the end of this one because it'll probably go on a little longer. So if you do have questions for Helen, you need to corner her afterwards, unfortunately. So it's just to let you know. Yeah, Helen?
Hi everybody, I'm Helen and I'm a freelance developer. I've been working with Python for quite a few years and this is my 5th Pycon UK. And this is my second time speaking here. Today I want to talk to you about Bluetooth Low Energy. Now you've probably used Bluetooth. It's a wireless technology, it's been around for quite a while, and you've probably got support for it on your phone or your laptop. Maybe you've used it for something like wireless audio or transferring files. Bluetooth Low Energy is a subset of Bluetooth. It was added in Bluetooth version 4, which came out a few years ago. You'll often see it abbreviated to BLE or BTLE, or sometimes it's called Bluetooth Smart. So I got interested in this. BLE has a number of features about it. It's made up of some very simple protocols. It involves transmitting very small amounts of data, like the temperature of a device, or what colour something is, or somebody's heart rate, and that doesn't use very much bandwidth. The protocols, I think they support up to about 10 kilobytes a second, but often we're using a lot less than that. It's a short-range protocol, and mostly operating within line of sight, or maybe the next room if you're lucky. And these things make it very low power. You're sending not very much data, not a very long way, and only when necessary. So when that's not happening, the wireless chip can be powered down, and you can run some of these devices on a coin cell battery for months or maybe years. It's also becoming quite common. You can get Bluetooth shoes that track the way you run. You can get toothbrushes, Bluetooth robots, fitness devices. And if you've got a phone or a laptop that was made in the last few years, if it's got Bluetooth on it, it's probably Bluetooth 4. And if you've got an up-to-date operating system, then it will support Bluetooth Low Energy. And this includes the Raspberry Pi, which is very, very straightforward to get running with a Bluetooth stack. If you don't have the hardware support, you can go out and buy a USB Bluetooth dongle, and that costs a few pounds. So I got interested in this when I was on a project that involved experimenting with some Bluetooth integrations and controlling Bluetooth devices from Python, and I saw how easy it was to interact with these, and it was really fun to just write code that controls something in the real world. I really enjoyed that, and it inspired me to carry on afterwards and try my own stuff. So I went shopping on Amazon, and one of the things I picked up was this. So this is a mains light bulb. It screws into a normal light socket. It's got red, green and blue LEDs inside it, and it says on the box it comes with an iOS app and an Android app, and they'll let you just control it from your phone and change the colours. It also says it's Bluetooth 4, which is important. So I got the app onto my phone and it was fine, it let me change the colour, but it's also a little bit limiting. There's only so much you can do with an app. I'm a programmer, I like to program things, and I wanted to do a bit more and be able to talk to it from code. This opens up endless possibilities. Maybe I could make it change colour depending on the weather. Maybe I could hook it up to a Raspberry Pi and make a cool light switch. Unfortunately, what it doesn't come with is a nice, friendly API. Yeah, unfortunately not, but that's one of the things we're going to have to figure out for ourselves. First of all, I want to get into a little bit of theory. So one of the high-level Bluetooth low-energy protocols is called the Attribute Protocol, ATT for short, and this defines the concept of an attribute. And an attribute is a value that's related to a device. It has a handle which is used to identify it, and that's just a number. It's got a UUID, Universally Unique Identifier, which tells us about the data. It tells us what type of data we're dealing with and the nature of the data. Now this can be something defined by the Bluetooth standard, so you have standard UIDs for things like heart rate, and vendors can also define their own. An attribute has permissions or properties, and this is a flag-based system, so you can have you have whether or not you can read it, whether or not you can write it, whether you can receive notifications, and for example, value of 2 means it's a read-only attribute. And then you've got a value which is the actual interesting bit, and that's the content of the attribute. Building on this, we have GAT, which is the generic attribute profile, and that uses attributes to build up a hierarchy of what we call services and characteristics. So a characteristic represents a property of a device, or something you can do to the device, and a service is a group of related characteristics. And when you can have multiple services on a device, and they will all together make up what we call the profile of the device. So it looks a little bit like this. So when a service is defined, there's one attribute used to declare it, and that's the service declaration attribute. And then you have all the characteristics in the service. And each characteristic is at least 2 attributes. So you have a characteristic declaration, which is metadata about the characteristic. And then you've got the value, which is the actual data. Sometimes you have other attributes to maybe describe a vendor-specific characteristic. But then when that one's done, you can define another one, and there might be another service after you've done the first one. I want to tell you a bit, before we do any practical stuff, I want to tell you a bit more about UIDs. So there are 2 types of UIDs. There are standard UIDs and Bluetooth defined UIDs. These are defined by the Bluetooth Special Interest Group, and these are the people that control all the Bluetooth standards, and that's abbreviated to SIG, and they define a lot of standard UIDs for different types of devices. All of these are based on the Bluetooth base UID, and UIDs that are based on that look like this. And that's a special suffix, and when you see that, it means that you can just refer to it with the first 32 bits, and you can take those, and you can look that up in the Bluetooth spec, and you can find out what that means. So it might mean something like heart rate, or GPS location, or something to do with the weather, like wind speed. So if you've got a device that conforms to one of these standard profiles and has standard UIDs, then when you get into it and examine it, it's quite easy to figure out what's going on and how you need to interact with it. Unfortunately, this isn't true for all devices. Not everything has standard UIDs. Things like light bulbs and robots and many other things don't have standard. There's no standard set of UIDs there. So vendors have to define their own, and they get to choose their own UIDs and what sort of values are sent to them. And they're probably not going to give you a nice little leaflet in the box that tells you what they all are. So we need to figure that out for ourselves, and that's when things start getting a little bit more interesting. So we're going to do some analysis on what the app does with the light bulb. And that's going to involve a few things. We're going to need, we need the light bulb itself and the app that goes with it. We need some analysis on some kind of desktop machine, and for that we can make use of Wireshark. If you're familiar with, if you've done any work with network protocols at all, you might have come across that. You need some way of getting files between the phone and the desktop. I prefer ADB for that. It comes with the Android SDK. And then there's the actual control element of this, and this is the part that actually interacts with the Bluetooth wireless technologies. And for that, unfortunately, the tools I'm using are Linux only. I'm doing this because I'm using these because they happen to be convenient and they're easy to work with. It does work with the Raspberry Pi as well. If you're using something like a Mac, there's probably alternatives on that. And you can always take what you learn from this and translate it to other Bluetooth APIs and other platforms. So I'm going to start by having a little look at the app itself. So I'm just connecting to this on my phone. You can see what it looks like. I'm not sure how well this will come up to everybody. Just connecting to it. This is the demo part where things are going to go horribly wrong and it might end in tears. I'm sure it'll all be fine. Okay, so I'm connected to the light bulb. I'm going to switch it on. And the app gives me this little color wheel, and I can just use that to change its color. So that's quite cool, and that's a fun thing in itself. I'm going to disconnect that for now. Okay. And I am going to go to a Linux terminal and see what we can do with this from, let me get into that window. Okay, so while the device is on, it's advertising itself. Let me switch that Bluetooth right off. It's not disconnected. So while the light bulb is on, it's sending out advertising packets, and it's saying, I'm here, and it's just broadcasting that on certain frequencies. And I'm going to run this tool called HCI tool. And this comes with the BlueZ stack, which is the Linux Bluetooth stack. And I'm going to type HCI tool LE scan, which means low energy scan. And that finds actually quite a lot of things. There must be a lot of Bluetooth around here. That didn't happen when I practiced. But this is the one we want. This is the name of our light bulb, the iColor Live, and this is its address. It's similar to a PC Mac address, and I'm going to copy that and use it. So I'm now going to use another tool called GAT tool. That also comes with the BlueZ stack. It's got 3 T's in it. I'm going to start that up in interactive mode. I don't know if everybody can see this. Give it the address. If you can't see what I'm doing, I'm putting all these commands into the slides as well, so I'll send them around afterwards. So I'm in GAT tool, and it's brought up the address. That blank space at the start of the line means we're not connected yet, so I'll connect. And now it says con. and that means I'm connected. So it's ready for me to start interacting with it, but I need to figure out what to actually do with it, because I don't know about its characteristics. So if I type in characteristics, I think I'm going to need to reduce my font size there. It's going to come up with a whole list of them. So there's quite a lot there. There's actually 26 of them, which seems like maybe quite a lot for just a light bulb. But if we look at this, if we look at one of them, so these are characteristic declarations, and so they're the metadata rather than the data itself. If we look at these, we'll see the first one. We've got a handle, which is a value of 2. We've got properties, which is 2, which means read-only. And then we've got a value handle, and that points at the value attribute of the characteristic, and that's going to be what we actually interact with. And finally, we've got a UID. Now that's a Bluetooth standard UID. This suffix means we've got a standard Bluetooth UID, and so we can just look at the front part of it, which is this 2A00. And if we look that up in the Bluetooth spec, that characteristic, that means device name. So I'm going to try reading out its value. How to get this? Let's try that. That's better. Char read UID, and then oops. Copy paste that. Just going to wrap around a bit. So we've got a value out of that. And we can also read it by its handle value. Its value handle. So we read that, we get the same values again. If you're used to looking at hex values, you might recognise that those are ASCII bytes. If you're really good at looking at hex values, you might be able to read them. I don't know. Anybody? Oh, okay. So that says iColor Live. So that's our device name, and we've just read our first characteristic. I'm going to look at one more. I'm going to go for this one because you might notice we've got some Bluetooth standard characteristics with the standard UID, followed by some ones that aren't standard UIDs, and so this is a vendor-defined UID. So we're going to try reading that one. I need to copy paste that. So char read UID, that value, and that gives us another value. So again, these look like ASCII values. In fact, they are capital O, capital C. This is vendor defined, so we don't know what that means. It could be anything. In the list of attributes, that we saw the properties, and that is OXA, which means it's read-write. We could try writing something to it, but we don't really know what that might do. We don't know what input sanitization we have. We might create a brick. We might just have a really frustrating experience of trying stuff and getting nowhere. So what we can do is, I'm going to get back to the slides a minute. Android has this neat little feature called Bluetooth Snoop Log. So if you have developer options enabled, you can go and switch this on, and it will start up a log file, and you can capture all the Bluetooth packets that are coming in and out of your phone. So what we can do is we can toggle that setting to start off a new log. We do the stuff that we're interested in the application. We download the log file from the phone to the PC and give it a sensible name, and then go off and do something else and generate more logs. So we can build up a picture of what packets the phone and the light bulb are sending between each other in different scenarios. And I've got So I've got an example of a session I ran with just changing the colour, and this is loaded into Wireshark, which has this kind of analysis of Bluetooth logs built in, and there's quite a lot of clutter in here at the moment. You see things like this HCI event, and quite a lot of these are low-level protocol things that we're not really interested in for this. So you can put on a filter. That's a little bit of a special value. It just it says please show me the attribute protocol stuff only. And when we do that, we see it's slightly clearer. We see all these write requests to handle number 28. And we can examine those a bit more. We look at this, and we've expanded the Bluetooth attribute protocol section, and we see it's written this value to the light bulb. Now, I don't know if everybody can see that, it's 7C00FF. If you deal with colours at all, that might look a little bit suspicious. We're thinking it might be an RGB value. We look at some more. There's 3200FF, and yeah, basically all of these are writing a 6-digit hex string, which is quite interesting. So I'm going to go back into GACTool, and I'm going to have a go. First, I'm going to read that handle, and yeah, that has a value which is. It's a little, because I've got it quite dim. The values aren't going to be that high, but it's quite high on the blue. So you think that might correspond to the colour of the light bulb. I'm going to try writing another value to it, because I'm confident enough now of what's happening. So I'm going to go for something quite low, because this bulb gets quite bright, and I don't want to dazzle anybody. So I'm going to try making it red, and it goes red. I'm just going to go for a nice bit of purple as well, and yeah, it seems to do what I think it should do, which is kind of awesome. So I've got that figured out, and we're at a Python conference, and I haven't done any Python yet, so let's do some Python. So I've got a little, let's just make the screen a bit bigger. So I've got this little file called disco.py. Actually, that's a bit too big. So we're using the BluePy module, the BluePy library. You can pip install BluePy to use this, and the important bit of that is the BTLE module, and we have a class called peripheral in that is what we mainly interact with. Actually, that's a bit. Okay, that's a bit clearer. So I'm setting up some color codes as we've just used. I'm reading in the address from the command line. That's the Bluetooth hardware address. Then I've got this little function called disco. It just takes in a sequence of color codes, and it writes all the characteristics in turn, and waits a second, and then does another one. So I'm doing here is just I'm creating an iterator that's an infinite loop of these three colors that I've set up. I create a peripheral, I give it the address, and then I run it. So I exit that. I just run that with the address name, and okay, there we go. We've just made a little Python-powered disco. So that's pretty much it. I just wanted to give you a bit of slide back. So this book has been a big help to me in understanding about these protocols. I started out just hacking around and not really understanding what I was doing with attributes. This gave some really good explanations, so I recommend getting into that if you want to know some more. I've got a few links. So the bulb I use, I've linked to that. I tried other bulbs, and not all of them were so easy to interact with. So it's a bit of potluck. But you can just search Amazon and go crazy by trying things. So link to Wireshark. There's also PyShark, which is better for processing log. If you want to process your Wireshark-based logs in a more automated way, that's really great. You can load them into Python and extract values in bulk. I forgot to actually tell you about Bluesy. So this is the Linux Bluetooth stack, and you can go there to find out about it and install it. It's fairly easy to set up. And then BluePy, which is the Python library that sits on top of Bluesy, and that's what we've been using in Python. Finally, a few links. So we've got the GATT specification, which gives lists of this gives you lists of standard UIDs, and so that's really useful for looking things up. I'm not exactly the first person to reverse engineer a Bluetooth light bulb. There are loads of examples of this out on the web with different light bulbs. Adafruit has quite a good one. They are They actually don't use a phone, they use a device called a Bluetooth sniffer, which I think it just sort of sits on the USB port and looks at Bluetooth connections. I haven't used one myself. And then there's some instructions for setting this up on a Raspberry Pi as well. If you've got a Pi 3, the hardware's there, and it's pretty straightforward. So I don't know how am I doing for time? 1 minute, okay. All right, yeah, I'm pretty much done. So yeah, thank you all for listening. I'm on Twitter and GitHub, and that's my website. So if anybody's got any questions, please come and find me afterwards. And if you want to have a go with playing around with the light bulb, just let me know.